were discussing about how to solve networks using mesh analysis. There are two terms are there, loops and mesh. Any closed path you find, that is a loop, okay. And mesh is one, mesh is also a loop, but within the mesh there will be no further loop existing. So, given a network, identify the meshes, assume the mesh currents in a particular direction, that is all mesh currents I have assumed it in clockwise direction, and then I wrote down the KVL equation. Let us take a numerically how simple it becomes now, you can easily see. Suppose you have a network like this, I will put some numbers now, say this is 3 ohm, this is 4 ohm, this is 7 ohm, this is suppose plus minus 10 volt, this is plus minus 12 volt, and this is another resistance, say 18 ohms, and here is another branch which is 12 ohm, and here is a voltage 7 volt, and here is another branch where is a voltage there, say 1 ohm, and this is say plus minus 4 volt. Suppose this is the network, all the currents are to be found out. Now, since I know now mesh analysis, I will try to apply that. How many meshes are there? 1, 2, 3, 4. How many loops are there? Many. This is a loop, but unfortunately in this loop there are so many meshes present. Similarly, this is also a loop, but 2 meshes are there. So, I will identify the meshes, I have identified that. Then what I will do? I will assume the currents, assign current to each meshes, that is I 1, this is suppose I 2, and this is I 3 I have assigned, and this is another mesh within which nothing is present, and this is suppose I 4. And mind you, what really I have assumed is this branch current I 1, this branch current I 4, and this branch current I 3, and others can be derived if one wish to find out. Anyway, this is I have done. Therefore, I have to generate 4 equations. First, in mesh 1, okay, I will write here mesh 1, KVL in mesh 1. Very simple to write. I will not spend any time or bothering too much about plus minus this that, those are days are gone now. Now, what I will do is coefficient of I 1 will be sum of all the resistances present here, 3 plus 7, 10 I 1. Coefficient of I 2, will it exist? Yes, there is a common resistance between these two, 7. So, minus 7 I 2. Coefficient of I 3, no, it will not be present. There is mesh 1 and mesh 3 is not sharing a resistance between them. So, plus 0 into I 3. Then will there be a term involving I 4 in this mesh? No, no common resistance, common wall between these two. So, plus 0 into I 4. In fact, these terms are not there, and this must be equal to the sources present in mesh 1. Now, what are the sources present? See, there is 10 volt and 12 volt. This 10 volt plus is in the same direction of I 1. the polarity of 12 volt is also in the same direction of I 1. So, 10 plus 12, there both of them are positive. So, 22. This is equation 1 is over. In mesh 2, let us write down mesh 2. You come here, coefficient of I 1, will there be a coefficient of I 1? Yes, common resistance between these two meshes, 7 it is, minus 7 I 1 preceded by negative sign. Coefficient of I 2 will be sum of all the resistances, mesh 2, sum of all the resistances. So, 18 plus 4, 22 plus 7, 29, and that will be plus. Will there be a coefficient of I 3 here in mesh 2? Yes, common resistance. So, minus 18 into I 3. Will there be I 4, the presence of I 4 felt here in mesh 2? Yes, minus 4 I 4. And this must be equal to the sources acting in mesh 2. Only one source is acting, 12 volt, and the polarity of this is such, it is in the opposite of I 2. Therefore, it will be minus 12. So, equation 2 in no time I will be able to write. Similarly, in mesh 3, KVL I am writing in various meshes. In mesh 3, you see, will there be a coefficient of I 1 in mesh 3? No, there is no common resistance between these two meshes. So, 0 into I 1. Coefficient of I 2 in 3, yes, minus 18 I 2. Coefficient of I 3 in this mesh. So, sum of these resistances plus 30. If I make a mistake, you please bear with me, logic is important, 20, 30 I 3. Will there be coefficient of I 4 in the KVL equation of mesh 3? No, there is no common resistance. So, plus 0 into I 4. And so, all the contribution of all the mesh currents as voltage drop in a particular mesh, that is 3 in this case, I have taken into consideration. Only thing on the right hand side I have to write down about sources. There is only one source present, 7 volt, and the direction of plus is opposite to this arrow. So, therefore, it is minus 7 volt. So, this is the third equation. And finally, mesh 4, very quickly let me write coefficient of I 1 in mesh 4, 0. Coefficient of I 2 in mesh 4, yes, there will be, because there is a common resistance, minus 4 I 2. Coefficient of I 3 in mesh 4, 0. And coefficient of I 4 should be sum of all the resistances present in this mesh, which is 5 plus 5 into I 4. Here it should be strictly speaking minus, since it is multiplied by 0, okay, got the point, 0 means 0. So, anyway, to be consistent, and plus 5 into I 4, 4 plus 1, and this should be equal to. So, all the mesh currents drop have been taken into account. On the right hand side, sources in mesh 4, the source is this 4 volt and its direction is opposite to this arrow. So, current direction arrow. So, it should be minus 4. This is the 4 equation. These 4 equations are independent equations, independent algebraic equation. involving the 4 unknowns, and these 4 equations can be solved. I am not discussing about how to solve these equations. Okay, algebraic equation, 4 unknowns, Cramer's rule, this that you apply, or go on reducing number of variables, this that you do, you get this. At the end, all the mesh currents you will be getting, and as it appears, it may so happen that one of the mesh currents become negative in number, say minus 2 ampere, I 3 becomes. In any case, that means I 2 will be flowing this way, those interpretation you can easily do. But nonetheless, after you solve this, branch currents will be a very easy task. In this resistance and 10 volt battery, this will be I 1 only. In this branch, it will be either I 1 minus I 2 if you show it from top to bottom, bottom to top, I 2 minus I 1 and so on. Therefore, you see, however slightly complicated networks you give, at least I am not spending practically any time to write down the KVL equations, because I know this logic, this is what it is going to be. That is the advantage. I mean, you go on writing this mesh analysis. How many equations you have to solve? As many meshes are there, that is fine. Now, I will take another interesting example to highlight this, because so far I have taken only voltage sources. There may be situations where current sources will be present. For example, let us take in this case, of course, I will not unnecessarily multiply number of meshes, I know what it is. So, let us consider a simple example. Say you say that you have a network like this. This is plus minus 10 volt. You can generate your own problems. That is how I am doing it, and you have say another voltage source like this. And this is suppose 6 ohm, and this is suppose 5 volt. And suppose there is a current source here shown, ideal current source 2 ampere, and you have been asked to calculate currents in all the branches. Now, you see in this network how many meshes are there? 2 meshes are there. What is I want to solve it by mesh analysis. So, what I have to do is I have to assign then mesh currents I 1 and I will mesh current I 2, that is what I will assign, is not 2 meshes are there, mesh currents, and I have to write down KVL in mesh 1 and mesh 2. But you see here it is an ideal current source, this current is 2 ampere, no matter what these other values are doing, any values you connect here, this branch current has to be 2 ampere. Now, in this problem what I am telling, the I 2 value is already known, this mesh current is 2 ampere, nothing can be better than that. I have to find out all the mesh currents, then I will be able to find out any branch currents I like, as I told you earlier. Therefore, in this case I 2 I will, it is given 2 ampere. That is why I am telling, if in a circuit current source is there, do not jump to this logic that somehow I must convert it to a voltage source. It is not necessary. Sometimes it is very advantageous. If a current source is present in any branch, it means that but branch current is known. Why you should disturb that? That is what I want to make. Anyway, this I 2 is known. Now, KVL in mesh 1. What will be the thing? KVL? Coefficient of I 1 will be 4 plus 6, 10 I 1. Coefficient of I 2, this is 5 volts I have taken. It will be minus 6 into I 2. So, this is minus 6 into I 2. And only 2 meshes, so 2 mesh currents, and on the right hand side I should write down the sources acting in mesh 1. It will be 10 because polarity of battery is such that it aids this I 1 direction, minus 5, is not, that is equal to 5. Now, as I told you, here how many unknowns? I 2 is already known. Therefore, I will write 10 I 1 minus I 2 value is 2 ampere minus 12 is equal to 5. Therefore, I 1 will be 17 by 10, that is 1.7 ampere, is not? That is what I will do, because I 2 is already known, no point, that is I will not try to write down the KVL in mesh 2. Whichever mesh current is known, I will not going to write down that, not necessary. Although, does it mean that KVL will not be satisfied? Yes, it will be, but you see in a current source, if this current is 2 ampere, this voltage, you have to take this drop now, drop here, drop in this current source and drop this of this 5 volt, that sum up will be 0, that is KVL, no one can avoid that. But unfortunately, if you want to write down the KVL at the beginning, you do not know what is the voltage across it. Got the point? You must, but anyway, it is so nice that then suppose I say let me complete this problem completely. So, this I 1 is correctly calculated. Na? So, I 1 is correctly calculated. Just check that if any mistake. This is 4 plus 6, 10 I 1 minus 6 I 2 is equal to 10 minus 5, and I 2 is known to be 2 ampere because of this. It is hopefully correct. Achha, then after you have got the mesh current, so I 1 is this and I 2 is 2. It is a good practice, not always necessary when you are very much used to it, to redraw the circuit. I will redraw the circuit. I mean, it is suggested at least when you are those who are getting initiated to this circuit analysis, they can find these interesting things. What I am telling, this was the original circuit 2 ampere, redraw the circuit plus minus 10 volt and this is 4 ohm and this is 6 ohm and this is plus minus 5 volt and this is this. But after I have solved this circuit, I know that this show the branch currents I 1, oh it has become positive, that means the direction of I 1 in 4 ohm remains same and it is 1.7 ampere. I write that. I 2 in any case is 2 ampere. Now, this branch current, apply KCL here. this branch current will be how much? I 1 minus I 2 if you write from top to bottom. What is I 1? I 1 is 1.7 minus 2 ampere. So, this will become minus 0.3 ampere, is it? 0.3 ampere from top to bottom. That means, actual current is flowing from this one 0.3 ampere. Yes, it should be 1.7 plus 0.3 is 2 ampere. See, in the network, ultimately I am interested to know what is the branch currents flowing in various parts. Got the point? Another point so this current becomes 0.3 now. I redraw the circuit, so the actual directions of the current like that. Then what will be the voltage drop across this resistance? Now, do not bring back this KVL mesh equations, erase it from the memory. I have got this. Then this voltage drop should be 6 into 0.3, that is 1.8 volt, with this side plus this side minus. Now, that is the thing. Now, as I told you that okay, you have solved this network, there is a current source present and the voltage of the current source is not known. Current is fixed, voltage could be anything, as in a battery, ideal battery, voltage between the terminal is fixed, current it will deliver depending upon what is the connected load is. Similarly, in the current source, current gets fixed, but what will be the voltage across it depends upon what are the other things connected across it. So, I want to know what will be the voltage across this current source. Suppose I say that this point is A, this point is B, calculate VAB, that is the voltage across the current source, potential of A with respect to B, and I know the rule, what it is, start from B, try to reach A via any path you like. So, I will choose say this path to reach A, start from this to this no voltage drop, no resistance, from this to this minus to plus. So, put a plus voltage rise of 6 into 0.3, that is the voltage drop here. Then from this to this, it is a battery, ideal battery, plus to minus 5. So, minus 5 is it, and this will be 1.8 minus 5, it will become 4.2, 3 minus 3.2 volt. So, potential of A with respect to B is minus 3.5 or 2, 3.2 volt, okay. Which means that VBA will be always negative of VAB, that is 3.2 volt, that is potential, the voltage drop actually here will be like this. B is at a higher potential compared to A. I told you in the previous class that given a network, you should be in a position to calculate potential difference between any 2 points of that network you like. These are very good things to know. If somebody says calculate potential between 2 points A and B of a given network, need not be this network, what you have to do is this, solve the network. So, calculate VAB, start, if it is VAB means potential of A with respect to B, start your journey from B, try to reach the point A, and whatever number you will get, that will be the voltage difference. If that becomes plus, that means A will be at higher potential than B. If that becomes minus, it is the other way around. Therefore, these observations you please try to understand always. And then next task, there are two sources. What if I ask what this 5 volt is doing? This battery, is it delivering power or absorbing power? 5 volt source, if you look at it, this is the polarity of the voltage, and through plus sign of this battery 0.3 ampere is coming out. So, battery is delivering. B battery is equal to 5 voltage into current is equal to 1.5 watt, and I write a comment delivering. It is delivering power to this network. What this current source is doing? This battery, what it is doing? P battery 5 volt, then P battery 10 volt. What it is doing? Is it delivering or absorbing power? Okay, from plus 0.7 is coming out. So, it is delivering. So, 1.7 into 10, that is 17 watt delivering. I don't forget to write these comments. What the current source is doing? It is also a source. In the current source, we have seen VBA is 3.2 volt, with this plus this minus 3.2 volt, and so voltage across the current source with this polarity, and it is absorbing current through its positive voltage terminal. Therefore, current source P current source is handling power. How much it is? Voltage into current. Voltage is this and current is this. So, this will be equal to 6.4 watt, is not 6.4 watt, but I must write something. Is it absorbing power or delivering power? I must write it is absorbing. So, mind you, in a network there may be several sources. Some of the sources may deliver power, some other sources may also absorb power. You charge a battery, then it absorbs power. So, a source may be charged in this way. Then what is the other fellows, how power balance taking place, that I leave it to you to compute. In the resistances, power losses take place. So, net power delivered to the circuit by the sources will be net power delivered by the sources, or total delivered power in the circuit is 1.5. This battery 5 volt delivered, 10 volt plus 17. These are delivered power. This must be equal to the power absorbed by different elements in the circuit. So, who are the fellows who are absorbing power? Resistances of course, will absorb power always, 1.7 square into 4 plus 0.3 square into 6 . These are the two resistances, and plus this current source we have noted, it is also absorbing power. I am not sure whether this is coming same as 18.5 watt, it has to. Okay. So, it once again make you feel comfortable, okay, everything is in place. So, in a circuit there may be several sources. Therefore, the final comment is this: when I adopt mesh analysis, number of equations to be solved is equal to number of meshes in general. But if you are lucky that in one of the outer loops there is a current source, then you have to solve less equations, because that mesh current is known, that you must understand. Therefore, in a network, if you notice that, okay, number of meshes I have identified 5, but in two of the outer meshes there are two current sources present. Therefore, you have to write down only 3 equations, because those mesh currents are known. In my next class, I will discuss what happens if a current source appears in the as a common branch between two adjacent meshes. Thank you.